Thanks, everyone. I'm very happy to be here today at Data Science Dojo to talk about AI ML workflow with Kubernetes. My name is Natale Vinto. I'm a developer advocate here in Red Hat for OpenShift. You can see in this slide the link to this slide. Those slides are public. If you want to follow along with the links we have in the slide, you can go to this link. We have also sent the link in chats, so you can follow along. Real quick recap about me. I'm a developer advocate here in Red Hat and also author at O'Reilly. Those are the books that I wrote. One is Modernizing Enterprise Java with another colleague, Marcus Eisele. You can download this book for free with this URL you find in the slide from Red Hat Developer Portal. The purpose of the book is talking about how to create microservices and to modernize Java application to run on Kubernetes. I'm writing another book with another colleague. This is the GitOps cookbook. GitOps is a very good paradigm for deploying application in Kubernetes, but not only. And we wrote this cookbook in order to collect a list of recipes on how to deploy application following the GitOps approach. You can see the early release of this book if you like. There's the link here, and we released the first 2 chapters. If you like, please follow me on Twitter. This is my handle. Add me on LinkedIn. And for people here in EMEA time zone, we have this show on OpenShift TV, which is our streaming TV where we talk all about cloud native, Kubernetes, and OpenShift, called OpenShift Coffee Break. Yeah. So this was me, and let's go into the topic of today. But before going there, I would like to remind that if you would like to follow along today with we're going to do an hands-on lab together. In order to do that, I think you have already the link in the chat. If you go to this link over here, and I can send it again in the Zoom chat, so you can also see that. If you go to this link, you're gonna arrive to this portal called Red Hat OpenShift Data Science Sandbox, where you can have a free account to run your Jupyter Notebooks, your data science workloads on Kubernetes and OpenShift. So if you want to follow along, please register. It's take a few steps, and then you can run the exercise together. All right, so before we go, this is the School of Athens, and I was preparing some kind of background music like into a museum. This is the School of Athens from Raphael, and you can see Plato, Aristotle, and Socrates in this painting. Well, you are not in the wrong streaming. What I was doing here is just using this analogy to ask who are you? Are you a kind of a Platonic data scientist? Are you an kind of Aristotelic ops, DevOps? Or are you kind of IT Socratic developer? Please use this poll on Mentimeter. I'm gonna also put the link in the chat just to understand who are you. I would like to understand what's the audience look like today in order to also, shape our talk and focus on some concept. If you go to this link or you point your cell phone to the QR code, you should be able to arrive to the poll. And I would like to see the result together with you. So to do that, you know what? I have to go back here and go to the live poll. So the question again, are you a data scientist? Are you a DevOps ops, or are you a manager? Actually, no, this is a Socratic developer. Let me fix very quickly. Yeah, are you a developer? Are you a data scientist? Are you a DevOps? Thanks for your vote. This is interesting also to understand what's the audience today, and also to shape our discussion. I understand there's an audience which is mostly data scientists, which is consistent, no, to the nature of the talk of the data science dojo. But it's also interesting that we have some DevOps person, some developer, because we're going to talk today also on how to make automation and how to help data scientists for their workload. So thanks for your vote. Keep voting. We will review the result at the end, but we understand that we have an audience which is mostly data scientists, which is cool, and we would like to hear from you, your feedback as well. So we talk about who are you. Thanks for your vote. Just have a quick overview of the people involved usually, no, in our processes, in our operation. We have the data engineer, the data scientist, like most of you, machine learning engineer, app developer, and IT operation, DevOps. So the people that cares also about the automation. If we want to split this a little bit on in terms of the functions, if you see here, this pipeline is split among all those personas. So the leadership is going to set the goal, and then the data engineer is going to prepare the data scientist is going to be in charge of develop the model, and the machine learning engineer, app developer, and also IoT operation, they are all involved in this integration of model monitoring and management. And if you see this diagram, this explains also what is a machine learning lifecycle in technical detail, no? Codifying problem and metrics, data collection and cleaning, feature engineering, model training and tuning, model validation, model deployment, and monitoring and validation. This helps us introducing what is a day in the life of a data scientist, right? The question I always ask also to myself: what does a data scientist care about? Or moreover, for non-data scientist person like me, which are more on the DevOps side of things, from some interview, we heard that as data scientists would like to have a kind of a self-service cloud-like experience with machine learning, some place where it's possible to access a set of modeling tools. And you can tell me also in the chat if that it's also your case, right? Because you want to perform your machine learning modeling, you want to do your model deployment, you want to do the inferencing with hardware acceleration. So real focus on what's important, which is the model deployment, the model developing, the model training. So if you will, this is the domain of the data scientist, right? Feature engineering, model training and tuning, model validation. And this process is also iterative. And here's where the automation can also help, right? We need to, we can create a kind of a pipeline linking the codifying the problem, the feature engineering, the model training, the model validation. This is if we consider those kind of building blocks, this is the domain where a popular software like Jupyter and the Python programming language Jupyter stands, which is the feature engineering, model training and tuning, and model validation. In fact, today we're going to do our hands-on using JupyterHub, Jupyter Notebook on a Kubernetes environment that we will talk about in a few moments. But talking about this context, there are some bottlenecks. How do we get started and how do we get into production? This is not trivial, right? We usually tend to do that in a manual way, iterative way. It would be good if we can automate this, moreover, for getting into production, because we have also many personas involved in this. And here's why Kubernetes, and here's where and why Kubernetes can help. Kubernetes, for people which are not aware of Kubernetes or not knowing Kubernetes that much, Kubernetes is a very popular open source project, and it's essentially an orchestration system for containers, for application packaged as container. This is very cool because it runs container workloads. The container technology itself today, it's really a mature technology. Having an application packaged as container ensure portability, ensure consistency, ensure also standardization around the standard format, and it also supported data science workload. So I can build my model, I can build my intelligent application as a container, packaging as a container. And if you look at this diagram this explains very good why and how this container could be done. It's some sort of layers where you have the base operating system, the runtime, Python in this case, JupyterHub. Those are layers, and those are inside the container. So you don't have to care much about installing all the dependency locally and then in the production server. It's all consistent in the container. And here's where the Kubernetes help. Kubernetes really help much on deploying such container. In Kubernetes terminology, those are pods, and scaling those containers. You can have your notebook scaled across a cluster and deployed on a cluster, and we will see in the hands-on how to do that. Kubernetes is it's a cluster with a control plane, data plane, and all such persona access this cluster, and everyone is doing their job, developing a front end, developing the model, training a model, or deploying the application. And Kubernetes is the place where you can perform all this operation. Let's go, before we go into the hands-on, let's go also into the automation of machine learning. There's this concept called MLOps, kind of a DevOps to machine learning. If we think about a data pipeline, we have to collect data, and then we extract the feature and store in some data store. This could be done with a pipeline. In Kubernetes, there's a popular project for creating automation and pipelines called Tekton. Is a Kubernetes native pipeline system. If you think about the machine learning training, it could be done in this way. From the data store, you start the model training, and then you start defining the model. You create a container image representing your model, and you store this container image in what is called the container image registry. And this runs inside a Kubernetes pipeline. After you have the building, you also want the release of the intelligent application from your model. So you store, in this case, you can use the GitOps approach. You store all your configuration in Git, use a Git workflow to start the deploying of the application. And this could be done with another popular open source software for implementing GitOps. And GitOps workflow on Kubernetes called Argo CD. Argo CD is in charge of monitoring change, detecting any drift, syncing all the change in the Kubernetes cluster. So the release pipeline for an MLOps operation can be implemented via Argo CD on top of Kubernetes. And to wrap up the MLOps journey, this could be one of the pipeline, one of the loop, where you start from the model training, you create the container image, and you deploy the intelligent application, and then you train again the model, and everything starts. I put in the slides a link of a MLOps demo we did with another colleague some times ago. If you would like to, please check out the demo. It's really cool to understand this MLOps loop. But today I like to talk more about ecosystem. So why Kubernetes could be really helpful in the life of a data scientist and the life of a machine learning and AI workload. Because there's a very rich ecosystem of software that help to compose your data science pipeline with building blocks. You have the CI/CD, you have Kafka, which is data streaming platform where you can stream the data, and we will see also in the hands-on there's a part using Kafka. There's a container registry, there's a Argo CD for the GitOps mechanism to build automatically the container from the source code. We will see also in the demo how. And also software like OpenDataHub, which is a collection of machine learning and artificial intelligence software. OpenDataHub is an open source, is a meta project, which is a collector of what we discussed before. No, we have different persona with different scope. The idea was to provide an end-to-end AI/ML platform for Kubernetes and OpenShift, which is in this case OpenShift is the Kubernetes enterprise version from Red Hat. So the idea is to make everything as a collection of software, and here you can see a pipeline from OpenDataHub. There's the storage, there's Spark, Jupyter, Tensor, there's a popular software called Kubeflow to deploying model as a service, and then you can deploy on Kubernetes and OpenShift and gather results and metrics. Kubeflow is another very popular software for Kubernetes. It helps defining model training, model serving, pipeline. It's kind of a collector of what we discussed, and it's available for defining the sort of automation that we discussed for the MLOps. In fact, OpenDataHub has everything like Kubeflow, there's Spark, there's Tensor, Argo, Kafka, everything lands in OpenDataHub, which is an open source project that you can check out at opendatahub.io. And it is the foundation of the product, which is Red Hat OpenShift Data Science that we will use today as a free sandbox on the cloud. But all that you see here, it's open source, fully open source. This helped also introducing the OpenShift Data Science, which is the collection of all the software, but in a supported way. So this gives you kind of a Jupyter Notebook as a service models. Then you have the mechanism to create automatically a container from a source code, and you can use when the hardware supported, the GPU acceleration and other hardware functionality. So this was the introduction. I would like to spend more time on the demo and question and answer. Again, as part of the demo, if you would like to follow along, you can register for free in the Red Hat OpenShift Data Science. You follow along with the instruction and you register very easily. There's also a part with Kafka, and we provide also a free tier for Kafka if you like to follow along. But what I would like to share also in the chat is this one, which is the link to the workshop we're going to implement today together. So let me exit this full screen mode because I would like to open this with you. So this is the OpenShift Red Hat OpenShift Data Science. And once you enter the OpenShift Data Science, and you register, you will have the access to the OpenShift Data Science sandbox. This is where your journey as a data scientist starts. There's a Jupyter Hub service that you can use to order and write your notebooks. And I would like with you to follow along with the instruction. So if you go here, this is step by step what you have to do, and we will do this together. So the first thing is get an account on OpenShift Data Science, and then start launching our Jupyter Hub. If we follow along with that, and we come back here, we just launched the application, and as you will see, this will launch kind of wizard, where we can select the kind of notebook image that we need, minimal Python, PyTorch, CUDA. We will use TensorFlow, and we will leave a default option. Here you can also use some other resource. You can inject environment variable, which are very useful when you work with container image. Is a way to make the container image dynamic. So When you order here, when you start your Jupyter Hub, this is gonna start the environment. It may take a few seconds, no? And after it takes, after it will start in your sandbox. So each one of you registering to the sandbox as its own environment. You are all in a big OpenShift cluster, so a big Kubernetes cluster, and you have all your user inside. And our journey starts from the Jupyter Hub. This is the launcher. Most of you are really familiar with this, right? The goal of today is implementing together an object detection workshop. And in order to do that, we're going to start from some source code, and this source code is available here. You have all the link in the tutorial. So this source code we're going to use, it's in the tutorial. So let's start from here. We clone the repository, and I hope if you can see my screen, or if I need to increase the font. So once you clone your repository, here you have your notebook, right? This is a sample one where just to check that everything is fine with this Cloud Jupyter notebook. So it looks that everything is fine. So the first step to start with is this one. It's exploring of the data science. We have some image already available on S3 in this case. So if we just follow along with the instruction, we're using TensorFlow. We're using some image because we want to do image recognition. And so we start from some docs that we put on S3. So we're gonna start from this image over here, and then we're gonna load a model which is already built in. No, the model has been already written. If you check out the source code of this repository, you can see the model. You can see more detail on it. What we wanted to do together today is give you a perspective as a data scientist. You can do your Jupyter Notebook as a service. And then we really go into the value of doing that on Kubernetes, taking benefit from the ecosystem of Kubernetes, the open ecosystem where you can build your application, deploy, and make your development cycle. So just here, I'm just following along with the instruction. Here we're defining the image, and then what we want to do as result for this notebook is have some boxes around the object that we want to recognize, and we want some recognition of the object. So this is gonna say, okay, this is dog with a certain percentage, right? And then we want to do as a final result, we want to do the same thing, not only from a static image that we retrieve from S3, we want to do also dynamically. And in order to do that, so this is the notebook to test that everything is working from a model perspective. It's very small here, but you can see there's a dog recognition with a certain percentage. And so that's good. It means that we are ready to identify object in image. And to do that, we will wrap it in a Flask application. So let's go to the other step. And if you are following along with this tutorial, make sure that you arrive to this point, and then you follow all the instruction, and then you went into the object detection where you had what we had until now. So here's the cool thing, no? We start doing also. We want you also to review the prediction function. So here is where we define our prediction function that also we can use in the application we're gonna package as container. Of course, we're gonna install some dependencies, in this case, the TensorFlow and all the Python dependency that we need. And after this is okay, we're gonna test the prediction function and visualize the result. So let's go here. This is the good to understand what we're going to do afterwards. Let me go quickly on that. And then since we will work on this prediction Python function. So this is our prediction function starting from a static image. If we want to package this as a Python app, we can run it as a Flask app. So to do that, we execute our instruction. And if you are following along here, please follow all the instruction. And we're gonna start the Flask app in this way. So let's do that. So here our application with the prediction function is running in this notebook. As you can see, we have the application loading. The debug mode is on. The next step, if you are following along with the exercise, is testing the application. So we're gonna go here and test our app. We give some second that this start. Okay, let's test our application. So we're connecting to the local host. So this is a connection local to this notebook, this Jupyter app instance. And as you can see, curling this the application with the Flask app, the status say okay. Now what we want to do is really going into doing a post to the prediction function, and as a result we have some scoring about the category that are present in some percentage in this image that we're working with. And as you see here, we're using we packaged the application into a Flask app. So the recognition is pretty accurate. No, dog 84%, dog 79%. So this is pretty accurate. What we want to do is making this also available as an application that we want to package and deploy on Kubernetes. And here how we can do that. So let's come back into our tutorial. If everything is fine, we can deploy our application as a source to image. If you recall the slide before, we say that there are many, Kubernetes offer many convenient way to automate and create a model from package it as a container image. One of these mechanisms that you find in this OpenShift data science instance is the source to image. Is a mechanism that helps you creating a container image automatically from some source code. In order to do that, if you are following along with the exercise, what you have to do is just go here, click and go to the OpenShift console. So this is the OpenShift data science dashboard where you can order your Jupyter app, create your notebooks. In the sandbox, you have this available for free in your free tier. If you want to have more, and there's also an ecosystem that starts into this environment, you can order more integration like OpenVino, Seldon. There are also partner involvement in this. It's an open ecosystem also for data scientists. But coming back to the deploying of our data, of our model, of our intelligent app, you have by default two namespace, do project. If you are not aware of the terminology of Kubernetes and OpenShift, a project is a container of your application, so your containers. In Kubernetes terminology, this is called a namespace. So we're gonna work into a namespace. You have to dev and stage. I created already a dev one because I wanted to show you also the application up and running with the Kafka part. But for this purpose, let's deploy our application from scratch from here. You just have to follow along with the instruction, right? It's really easy. And it's really easy with OpenShift to create an application automatically on Kubernetes. If you go to this console and you click on the left, there's this add. There's many ways in OpenShift to deploy an application. You can deploy from a Helm chart for people aware of Helm. You can deploy from an existing container image, or you can deploy from a source code. Deploying from source code is really easy. You just point to the repository where there is the source code. This is a repository containing, you know, the Python code. The Flask app is there. The only thing you need to do here is just make sure that OpenShift guessed rightly the runtime, and this is a Python runtime, so it's okay. And then some setting like what's the name of this application. The name is object detection. What's the name of this deployment, which is object detection REST. And some few setting like this is a Kubernetes deployment. You want to expose the traffic outside, you know what? You can also decide to have a secure route. That means you want HTTPS. You can select that, and after that you just create the application. So here's the magic. So we are converting our Flask app containing our prediction function into a container image deployed into Kubernetes. We haven't had to do anything like you know, creating a Docker file or just moving that to some other part. This automation is so smart to start from the source code and create a container image on the fly. You could also use, for instance, a Tecton pipeline to do that. If you imagine multiple prediction function or multiple notebook, multiple application that you want to convert, you can make multiple pipelines. And the final goal, it's always create the container image. So this is gonna, you know, run the pip install with the requirement, and the final result of this will be having your application up and running in Kubernetes. You can also follow along here, no, with the instruction. As you can see, the build is going to take, you know, some few seconds. The cool part after this finish is that we test our application. To test the application, we can go back to our notebook where we test the application. In that case, we verify that this is up and running. So our next step is, okay, verify that this is up and running and it has finished the function, and then going into using the prediction function in order to use it from the notebook. So what we have to do is come back here and then change this host name with the other one that we have from the compilation. Since this may take some time, no, some few seconds, and we can, we can follow along with that. Pushing the container image is the final step. This means that the container image has been created, and then the application is able to scale up and be deployed on Kubernetes. So once, let's wait a few seconds more just to understand if this is completed. Yeah, it looks it went through, and this is our application. The application is starting from a container image, deploying on Kubernetes. Now what we have to do is again if we follow along with the guide here, we just have to substitute this object and we can test everything. So if you are arrived also here, and you can see, and you have set up everything. What we want to do is testing that this is up and running. Let's see if we have a kind of a status okay, like we were having in the Flask application. Let's wait a few seconds. It may take some time to start. Probably is taking a few more seconds. But I would like, in the while that this goes through, and it went through, okay, our application is up and running. So let's go here and change this, not to the local Jupyter Hub instance, but we let this going into, and I can put also the link in the chat, no? We let this going into that host, and now what is answering is not the local Jupyter notebook, is the one we packaged as a container. So we can always refer to this model, to this intelligent app, because it's there. In fact, the other exercise is calling from an application. Now, if we have the developer that want to help us in creating a nice application where we can test this out, we can create another application in the same way we did before. We deploy this application. This is a front end, so the JavaScript part. So the developer now can join our work. We are working together here in the OpenShift sandbox, OpenShift data science sandbox. We're gonna create an application again in the same mode. So this is the detection app. It's a Node.js application. This is going to do a deployment. I'm gonna create again a secure route, so it's all HTTPS. One thing to remind here, we can also inject environment variable, and I think here we're gonna inject the environment variable from the local networking to reach the application. So the only thing we need to do is go in here, create this environment variable, and say, please connect to the local, to the application we just deployed. And the application we just deployed is reachable either outside with the link I gave you, but also inside. We want to use the prediction function inside with the Kubernetes internal networking. We don't want to go outside. Again, the same thing. If we go here, this is gonna deploy a new application, building a new application, which is logically linked to our notebook, our model. And in fact, if we go back here, the final result is that we have our application up and running. The application is an object recognition, and this is gonna use your camera if you want to try it. This is gonna use your camera, and will try to dynamically recognize what the camera can see, and we can see it in a moment. We have just to wait that the application start. But if we don't want to wait, you know what, this is gonna take maybe some little while. We can go into what I was already deploying before, and if we go here, I want to let you see. This is gonna use actually the second camera, and if I do a picture of myself, and let me send you the link. So this is a picture of myself. Is recognized the human face, the shelf, the microphone. Somebody of you asked which microphone. This is a Shure microphone. Sorry. I'm gonna put my red hat here with the headphone. Is difficult, but let's see if it recognizes that I have a fedora. Let's check. Yes, fedora 20%. Maybe it's not confident on how I'm wearing this fedora, but you know what, is working. And this is what I wanted to do, kind of a live demo of object recognition. And the second part, actually, the second part that I wanted to show you, we don't have time to do that, but I can show you from the working side, is connecting Kafka to that. So why Kafka? Because Kafka is very useful for streaming data. So we want to, if we think about a video, no, this is just an image, but if we want a video to stream the data, invoking the prediction function multiple times for each frame, we can take benefit of a streaming platform like Kafka. If you follow along with this instruction here, it's gonna create a Kafka instance. You can use Kafka if you have on some Kafka cluster somewhere, or you can use this free tier we offer here at Red Hat with managed Kafka. I put the link in the chat, and let me be sure you have the link also there. If you go to this link, Red Hat try Kafka, and I make sure that you have it. You can also order a Kafka cluster. What I did is I just created a Kafka cluster called Data Science Dojo. I created inside the Kafka cluster 3 topics. One is for the images, one for the objects, and my application. And then I deployed another application containing the information to log in to Kafka. So you have to do some setting to create the Kafka topics, some username, password. Once you have your Kafka cluster and you have your username and password, you can inject in the notebook, just restarting the notebook as an environment variable. But also you can deploy a Kafka consumer as an application, again with all the credential. The final result of this, and I leave this to you as let's say an exercise, is that if you go back here, you can also create you can make sure that you are using a video mode, no? And this is kind of trying to recognize while you are talking, while you're moving, it's trying to recognize all the scoring of what you're using. Again, let me find my wonderful Fedora. Here the Fedora has also hat. It's just hat. Let's see if Fedora comes through. Oh, okay. There's Fedora. Yeah. So if you see this is using a multiple frame. Those frame, the prediction function is invoked during the framing, and this is pretty cool. And you can try yourself. You have also the link in the chat to try this with your camera. But you know what? You can also deploy on your OpenShift data science sandbox, so you can try everything. I was working here, it take a little while to deploy that, but you take once it takes the time to deploy the application. Those are container application packaged from the source code. So if we think about the user experience for a data scientist, we come back to that slide, say, as a data scientist, I would like to have a self-service cloud-like experience. It looks like this Jupyter Hub as a service, the rich ecosystem, the way you deploy the application. You can access a rich set of modeling tools. You can include all the, the project, and you're taking benefit also from Kubernetes ecosystem, where you can create automation for creating container, storing the container, deploying intelligent application, automation again to create the container image, and taking benefit of a rich ecosystem of open source software done with Operator Hub and OpenDataHub. In this case, you take benefit of using Red Hat OpenShift Data Science, which is our cloud services around OpenDataHub. And the OpenShift Data Science Sandbox is for free. So you can start doing your AM, ML workflow for Kubernetes for free. This was the demo. The Kafka part is really cool. I'll leave that to you. Just to close up, I would like to give you, and then we go into the question and answer, if any. I would like to leave you some links. You have all the links in the also. You have all the links in the slide, but let me again give you the link of the OpenShift data science. If a very cool link and resources, the developersredhat.com. Here is where we write all about cloud native, open source data science. You find many resources, many articles talking about how to do machine learning with open source. This is one of example. If you like to have a look on how to create microservices for Kubernetes, this is the book Modernizing Enterprise Java, in case you are also familiar with Java, helps on understanding how to create an application on Kubernetes. And if you like to start with Kubernetes and OpenShift, we have this free environment called Developer Sandbox for OpenShift, where you can start creating application on Kubernetes, connecting to your OpenShift sandbox, and work on a free environment like the OpenShift data science sandbox. So those were all my links today, and I'm available. I thank you for the attention. It was very cool to be with you today, and I'm here for any question and answer.
All right, thanks, Natale. So if you do have any questions, please post them in the Q&A tab. That'll just help us keep them organized. YouTube, LinkedIn, any live stream, just go ahead and ask your question, and I'll make sure to either say them out loud to Natale or post them in the chat forum. And Natale, I know we have one question in the Q&A tab if you have that pulled up.
Yes.
You can try your best to answer that, but yeah.
Yeah, the question, what is the correct plan for entering a statistician as a data scientist? I think this is a very specific to a data scientist. I think I'm more close to the MLOps world, the Kubernetes world, helping the data scientists. So I'm not really sure what is the correct plan for entering a statistician as a data scientist.
Yeah, and if you ask that question, feel free to visit datasciencedojo.com, schedule a call with an advisor, and we can help you answer that. And that's actually the only question I'm seeing. So maybe we give it a couple more minutes and then we'll get going.
Yeah, there's another question. What is the path of learning the Red Hat OpenShift? We have multiple paths. If you go to the website developersredhat.com, we have a multiple learning path to start learning OpenShift, and using Developer Sandbox for OpenShift is really a good way to start learning it. So we have also some interactive labs around that. So I really recommend you to go to the website I share in the chat. You have a very starting point to start learning Red Hat OpenShift. There's another question. Do you know any course that can help learn this workflow in more detail? Well, yes, we have. If you go to the landing page of Red Hat OpenShift Data Science, we have more labs, more exercises that you can use. If you go to this website here, there are more articles, more resources to start learning about OpenShift Data Science and OpenDataHub. If you click on Getting Started, you will see those learning paths. I think they're really cool because they help us. They help everyone, to start learning in this way. So let me reach also the chat. So this is very good starting point. I think you have the learning path. So how to launch it, the resources, how to work with S3, TensorFlow model, NLP, with all the exercise we've seen today It's part of many exercises available. Those are all the docs and tutorials. So if you go here, you find many resources about MLOps and AI/ML workflow for Kubernetes. But thanks for all your questions. There's one question. I'm learning Kubernetes and Docker to scale data science application. What is the best way to connect to people and find relevant job opportunity? Oh, that's a good one. I think best way, you know what, is joining the community. We have many communities like the OpenDataHub community. If you join the PyTorch community, TensorFlow community, if you join all those community, you have the connection for the people using that to learn and also to hear about any job opportunity around the field. And I'm sure, Nathan, you can share more about data science community, since you are a very good data science community.
Yeah, join our community. A lot of our presenters, like Natale, they like to connect with everyone who joins. So, join the community, interact with the community, leave comments, join our community events. And then also, I just posted in the chat our next community event, which is called ACE, the Data Science Interview, where our presenter is going to be talking about data science interviews. Also a great person to connect with. So, my biggest thing is just be engaged. Don't shy away from networking or asking questions.
Yeah, that's important. It really answered that question, I think. We have another question here, like what's the difference between Kubernetes and Docker? Well, while Docker is a container engine, so with Docker you create container and run container, Kubernetes is a container orchestration. So Kubernetes deploy your containers in multiple worker nodes. Can be physical server, virtual machine, can be anything. So the difference is that Kubernetes is an orchestrator of containers, while Docker is just an engine that run container. It's not meant to be used for high availability environment. It's just more if you use Docker alone, it's just more for local development rather than more kind of production environment. And Kubernetes is very, very popular for doing that, and very, very used. In fact, OpenShift is using Kubernetes is an enterprise Kubernetes because it's a very valid software for deploying application, and as we discussed, a very rich ecosystem, open ecosystem, where you can connect multiple things, like all those data science open source software. I see another question from the Q&A. What's the difference between Red Hat OpenShift and other platforms like Azure or AWS? Oh, well, that's a good question. Red Hat OpenShift is a product which implements a Kubernetes. So you can see OpenShift like a Kubernetes enterprise edition that you can run everywhere. Can be on bare metal or even on Azure or AWS, like you said. So OpenShift really runs container. Azure and AWS, those are two public cloud. They run multiple things. They run virtual machine, they run either container, they run even OpenShift. We have a managed version about OpenShift on AWS called Rosa, and a managed version of OpenShift on Azure called Arrow. So the main difference is that OpenShift is really agnostic, portable Kubernetes, enterprise Kubernetes, while those two are public cloud, offering multiple way to work with, like virtual machine or container. Thank you. That's
So, sorry, Natalia. Let's do one more question, and then we'll have to let you go.
Yeah. We are at the end of the session. I take the opportunity to really thank you. It was really a pleasure to be with you today. And let's see this question. Does OpenShift is free for install now, or must be installed OKD4? And this ecosystem could run on OKD4. Okay, so OpenShift, it's OpenShift is the product, Red Hat product. All the software used by OpenShift is open source. Everything is open source here in Red Hat. The upstream, we call it upstream and and downstream. The upstream bits of OpenShift is called OKD. If you want OpenShift, you can use it for free with this sandbox, or you can use download a local instance of OpenShift called Code Ready Containers. It's a free instance of OpenShift that you can use on your laptop. So those are other kind of free flavors. The sandbox is always free. So if you want to use it like that, OKD is the upstream bit. OpenData, I don't know if OpenDataHub runs on OKD. I can check that. I guess so. But this specific that you see, OpenShift Data Science, runs on OpenShift. So you can use it on OpenShift, and you can use it. This is the tool we are using for this sandbox.
Okay, Natalia, I think if we don't let you go now, you'll be around forever. So thank you so much for coming today. I think everyone really enjoyed your session, and based on the comments, really learned a lot today. And thank you, everyone. If you're still here, thank you for joining.